In this problem, we will prove that 1 plus n to the power of n is greater than or equal to 2n to the power of n for n a positive integer, and for that we will use Bernoulli's inequality. So in this video we will start by proving Bernoulli's inequality, and later we will see how to use it in our inequality. Now let's prove Bernoulli's inequality. Here we will prove that 1 plus x to the power of n is greater than or equal to 1 plus nx for x greater than or equal to minus 1 and n a non-negative integer. So let's start with the base case. Base case meaning our n is equal to 0. So here we will have 1 plus x to the power of 0, of course, which is equal to 1. And here we will have 1 plus 0x, which is also, of course, equal to 1. So we have 1 plus x to the power of 0, which is 1, is greater than or equal to 1 plus 0x, which is, of course, 1. So the base case, of course, holds. Now let's prove the inductive step, meaning that we will prove that 1 plus x to the power of n is greater than or equal to 1 plus nx for some non-negative integer implies that 1 plus x to the power of n plus 1 is greater than or equal to 1 plus n plus 1x. Of course, since we have this inductive hypothesis, we will just multiply by 1 plus x. Since here we have x greater than or equal to minus 1, we will have x plus 1 is a non-negative number, meaning here that we can multiply by x plus 1. So here we will have 1 plus x to the power of n times 1 plus x, or x plus 1, is greater than or equal to 1 plus nx times 1 plus x. And here, of course, it's 1 plus x to the power of n plus 1 is greater than or equal to, here distributing 1 plus 1 times x plus nx times 1 nx plus, of course, nx times x nx squared. Of course, meaning that 1 plus x to the power of n plus 1 is greater than or equal to 1, and here we have x as a common factor. So here we will have n plus 1 times x, of course, plus nx squared. Now, since nx squared is non-negative number, n is non-negative number, and x squared is non-negative number, we have nx squared non-negative number. We add this number to both sides of this inequality, 1 plus n plus 1 x. So we'll have 1 plus n plus 1 x plus nx squared is greater than or equal to 0 plus the same number 1 plus n plus 1 x. And now from those two inequalities, we have this number is greater than or equal to this one, and this one, the same number here, is greater than or equal to this one, meaning that we will have 1 plus x to the power of n plus 1 is greater than or equal to 1 plus n plus 1 x, meaning that the step holds. So from here we can conclude that for every non-negative number n, we have integer, we have 1 plus x to the power of n is greater than or equal to 1 plus nx. Now let's prove our inequality here. So for that, we will set x equals 1 over n in our Bernoulli's inequality. And we will have 1 plus 1 over n, which is x, to the power of n is greater than or equal to 1 plus nx, n times x, which is 1 over n. Now here we have the same denominator is n, so we'll have n plus 1 over n is greater than or equal to, and here 1 plus n times 1 over n times 1 over n is 1, and 1 plus 1 is 2, meaning that we will have distributing the power here, we will have n plus 1 to the power of n over n to the power of n is greater than or equal to 2. The final step is just to multiply by n to the power of n, so we'll have n plus 1 to the power of n is greater than or equal to 2n to the power of n. And this, of course, concludes our problem.